Welcome back to Medical Physics. Today we are going to discuss about ultrasound and its application in medical field. Before going to discuss about ultrasound, first you have to know what you mean by sound, how the sound is produced, and classification of sound energy. The sound is nothing but it is a mechanical vibration which are produced by the vibration of the particles. In air, the vibrations are purely longitudinal, but in solids, the sound wave can be longitudinal or transverse in nature or combination of both. The speed of sound in air depends upon the temperature and humidity present in the air. For dry air at a temperature 0 degrees Celsius, it is about 330 meter per second. The speed of sound through solid is much higher. Example, steel, it is in the order of 6000 meter per second. So depends upon the frequency of sound energy, which is classified into two categories, audible sound and inaudible sound. The audible range of the frequency of sound is 20 Hz to 20,000 Hz. The inaudible sound below 20 Hz or above 20,000 Hz. Both are all not able to hear the human bodies. The sound for frequency below 20 Hz are called as infrasonic sound, so which are produced from elephants, airplanes and thunderstorms, fast moving cars, very loud music. So sound which has frequency less than 20 greater than 20,000 Hz are called ultrasound or ultrasonic sound. What are the important properties of ultrasound? So in this chapter we are going to concentrate only the higher energy of sound, that is ultrasound. The ultrasonic sound vibrate at a frequency is greater than audible range for human being, that is more than 20 kilohertz. They have smaller wavelength, as a result their penetration power is more. So smaller wavelengths which indicate the higher frequency. They cannot travel through vacuum. Ultrasonic wave travel at the speed of sound in medium. They have maximum velocity at the denser medium and minimum velocity in the rarer medium. In a homogeneous medium, they travel at a constant velocity. In low viscous liquid, ultrasonic waves are produced in vibrations. They undergo reflection, refraction, and absorption. They have high energy content. They can be transmitted over a long distance without much loss of energy. They produce intense heat when they are passing through the objects. Like sound wave, the ultrasonic sound wave longitudinal wave that produce alternating compression rarefaction during their passage. So these are the important properties of the ultrasonic waves. Now we discuss about how the ultrasound is interact with the matter. When the ultrasonic wave which is incident on the material particle may be resisted from the material, that property is called acoustic impedance. So the acoustic impedance is the resistance of the material for the passage of ultrasonic wave pass through the material, or here we discuss about body tissue. The acoustic impedance is given by the ratio of wave acoustic pressure to the volume velocity. That is, Z is called as acoustic impedance, which is equal to pressure by volume. The unit of specific acoustic impedance is a Pascal per second, Pascal second per meter, often called as rad. Medium in which speed of sound is different generally have differing acoustic impedance, so that when a sound wave strike an interface between two, it encounter an impedance mismatch. As a result, some of the wave reflects while some is transmitted into the second medium. If the tissue has higher impedance and is less likely to allow ultrasound waves pass through it. It also means more wave will be bounced back towards the transducer. So the acoustic impedance, which is highly depends upon the density of the tissue and the speed of sound waves. So the acoustic impedance, which is equal to density into speed of light. And also the following process which are occur when the ultrasound wave is passing through the medium. So ultrasound wave, they can strike a medium, cause expansion, compression of the medium. When the ultrasound wave reaches the interface between the two medium, the four things will be happen: either reflection, scattering, refraction, or attenuation will be happen in the material. What do you mean by reflection? A reflection can be categorized either specular or diffuse. Specular reflection are large, smooth surfaces such as bone where a sound wave is reflected back in singular direction. Greater the acoustic impedance between the two tissue surface, the greater the reflection and brighter the echo will appear on the ultrasound. Conversely, the soft tissues are classified diffuse reflector where adjoining cells create an uneven surface causing the reflections to return in various directions in relation to the transmitted beam. A reflection of sound, which depends upon angle of incident, acoustic impedance mismatch, width of the tissue boundary, the angle of tissue boundary. So these are the parameters will disturb the reflection occur in the body tissues. A refraction. A refraction occurs when the ultrasonic signal is deflected from the straight line path and the angle of deflection away from the transducer. Ultrasound wave are only refracted at a different medium interface of different acoustic impedance. Refraction allows enhanced image quality by using acoustic lenses. A refraction can result in ultrasound double imaging artifact. Scattering of sound. Scattering occurs when a sound wave strikes a structure with a different acoustic impedance to the surrounding tissues and which is smaller than wavelength of incident sound wave. Such structures are known as diffuse reflectors, with the example being red blood cells on non-smooth surface of visceral organs. If a large number of small tissue boundaries occurs, the scattering can radiate in all directions. Most scattering occurs with the red blood cells, which have the width of 7 to 10 micrometer, which is 20 times smaller than the ultrasound wavelength. Attenuation or absorption of ultrasound. In ultrasound, absorption is a reduction of intensity of sound wave as it is passed through the tissue. Most of the energy lost in the form of heat. When the ultrasonic wave propagates through a medium, the energy reduces. This phenomena is called attenuation. Therefore, maximizing the amount of energy received by the transducer after the wave interact with the tissue is essential to produce high quality. During the attenuation of ultrasound wave stays on the same path is not deflected. As passed through the tissues of different densities, the amplitude decreases. If all of the ultrasonic wave energy is observed, then structure distal to the point of total attenuation will not be visualized and will appear as a drop. This is called a dropout. That is, you cannot able to capture the image of an object. The following factors which affect the attenuation: the transducer frequency, acoustic impedance mismatch between the tissues. So these parameters will affect the attenuation mechanism. Thank you.